Yes, sir.
Okay, so
Yes, sir.
right now I am going to start the new topic. New means last topic of my electrical instrumentation, electrical measurement and instrumentation course. This is our last module. Okay, sensor and transducer. Okay, so basically now I am in almost verge of the completion of my course. Okay, so I am in last module. So I think these terminologies like sensor and transducer, these terminologies are very well known from your side. I think so. So all of you are those who are working on different club or different societies like robotics, especially on that robotics club, and different societies are there. Okay, so in SAC, okay, those who are working on it. So especially for the robotics, so they are very much known about that concept, that sensor. So normally what happen in sensor, so before starting any of the course, I am always telling you that you have to know the basic motivations of that chapters or of that course. Otherwise, if you have that if all the logic is clear from your side, so then you can only understand what is the significance of this syllabus, why we are much more why we are giving much more focused on it. Okay, that is our mandatory one. Okay, that we need to know in very well manner. We need to know very good way. So first we have to know what is sensor and what is transducer, and then we need to know what is the importance of this subject. So why we are much more focused on sensor, transducer, and how we are going to be implemented. Okay, so basically in my previous class, in any of my lecture, I told about you that basically the difference of that sensor and transducer. Basically you can say like that sensor, transducer normally are related to about your conversions of any of the physical quantity to electrical quantity. Okay, so like that one, you can say like that Hall effect sensor means voltage transducers. Okay, voltage transducer means some of the voltage transducer like helium makes some transducers are there. They're converting. Okay, so they are converting that voltage. Okay, they are converting that. Sorry, that converting that any of the physical, any of the you can say like that physical parameters. Okay, what type of physical parameters? So you can say like the tacho generators. Okay, in tacho generator the rotations are there. Okay, so rotations are there, that rotations are converted to your that rotation is converted to your voltage, means tacho generator. Similarly, that voltage sensor are there. So magnetic fields normally you are using there, the magnetic fields that is responsible to convert the equivalent voltage level. Okay, so equivalent voltage level. So that kinds of things you can normally focused about in transducer. But in case of sensor, you cannot say like that only physical quantities are converting. Okay, so any of the physical quantities, definitely the physical quantities are converting in any of the mode of energy, not like only the electrical energy. Okay, so in transducer mandatorily output is your electrical, means any of the physical quantity is converted to the electrical quantities. Okay, but in sensor they are converting any of the physical quantity to other measurable quantities. Okay, means you can say like that sensors means it may be heat sensor. Okay, heat sensors may be like that. Sometimes you can say like that may sensing the heat, but output is not the electrical one. You can see the temperature control of the electrical ovens. Okay, so some of the heat sensor are there, but it is controlling the temperatures. Okay, it is temperatures, or you can say like that it controlling the electrical temperatures related to directly electrical measuring unit. So so you can say like that there will be some possibilities of the electrical energies, but some of the applications are still there that is not directly related to your electrical measurements. Okay, so sometimes different applications will also be there. So that is the basic difference of sensor and transducer. So transducer can convert the any of the physical measurement to the electrical quantity. Okay, and in case of sensor, that any of the physical quantity is will convert to the it may be electrical, okay, it may be mechanical, it may be chemical output like that way. Okay, um, so I think all of you able to understand that problems, sorry, that motivations of this chapter. So this chapter we are much more focused about to know the operations of different type of transducer and the sensor and different examples of that. Okay, so this is most important topic because of what that I am telling about different measurement. Okay, so that voltage is sensing through this voltage is sensing through this. Okay, so we can sensing the voltage. Okay, so that LEM sensor means voltage sensor, and and comparing those values with our reference value. Then some of the controller is there, and controller is responsible for generating the PWM. Okay, that PWM is control the solid state devices, or we can control the heat. Okay, so we can control the electrical connectivity of that of that electrical ovens. Okay, so on a if that pulses is responsible for that on off of the switch of that electrical oven, so that we can easily control the temperature of the electrical oven. So that's why this transducers, you can say like that, output is electrical energy. That's why you can say like that LEM voltage sensor is an transducer. LEM current sensor also an example of a transducer. So here we are discussed about the basic idea of the transducer. Okay, so that we are known from us that a transducer is a device that convert one of the energy to the another. Okay, so definitely it's an electrical energy. Okay, it's an electrical. In sensor, definitely input transducer called the sensor, and output of the transducer is called the actuator. Okay, that I am telling you now. So one example, like in my initial classes of measurement, that I told you that some of the temperature sensors is there in our skin. We're just touching the hot bowel. Okay, so that means our heat sensor are there. Okay, that heat sensor are there, that is sensing the temperature, and the sensory neurons are there, that value is converting, the transmitting from your hand to brain. Then brain is processing that how much value of that heat is there, means temperature of that bowel is there. If it is in the tolerable range, then no problem. Actuator is your muscles. Okay, so muscles are your actuator. So if that temperature is too high, then brain send you one signal through the motor neuron to the actuators, means muscles of that hand or leg, like that way. So that as early as possible you just remove your hand from that hot bowl. Okay, so how much time is required? That response time is important. Okay, that sensitivity of your system, that I'm asking you. So you can say like that it is heat sensor, and it is converting to the chemical, maybe electrical, in human bodies, in any of the living bodies. Okay, so if it is converted to the electrical, so you can say like that it's an example of a transducer. But if it's an converting to the chemical sensors, basically in our human body, like totally the conversion in the electrical one, so it's a electrochemical process. Okay, electrochemical process, that's why you can say like that it's a sensor. Okay, so some of the portion is responsible for chemical changes, and that chemical changes is responsible for electrical changes to our transmit that signal from our hand to brain. Okay, that's why it is called that sensor. Okay, and your output transducer is an actuator. So here we are taking one example. Okay, so we are using some microphone. So microphone is there. So in microphone we are giving some of the input. Okay, so input is there in microphone, and then control system is there that is responsible for the amplifications of that signal. If that signal is amplified, then we will get that output. Output is here. I've output from that loudspeaker is there. So due to that sound wave, so automatically that amplification is there, that is responsible for loudspeaker, so we can hear that voice loudly. So actuator, which one is your actuator? That loudspeaker, the input of the loudspeaker is called, you can call like a actuator. And your transducer means there is a diaphragm. Okay, so we are giving the sound wave. Now that diaphragm of that microphone is, it's what, it is vibrating. To the vibrations, the some electricity is producing. Okay, that electricity you are making it amplified because the strength of the electricity is very less. Strength of the current signal or strength of the electrical signal is very less. That's why that amplification is required. So it's an example of a transducer. So diaphragm, that movement of that sound wave. Okay, so sound wave, that vibration is there. Vibration is responsible for developing that electrical signal. Okay, so that's why it's an example of a transducer. So you can see we are written in the head of transducer. So you can see the diagram. Okay, so input and output of the transducer, you can see the diagram. So sound wave, you are providing that sound wave. Due to the sound wave, so it is your layer of that sound wave, then flexible diagrams are there. Okay, it is a flexible diagram. So magnets are there because of that on diaphragm support is there. Due to that diaphragm movement, some vibrations. Okay, that diaphragm is there. That due to the diaphragm movement, that vibrations is there, and due to the vibrations, the magnet is there, and you can see that movement of that conductors. Okay, movement, that conductors is connected in the outer leg of the diaphragm, and magnet is, now diaphragm is moving means a conductor is moving. Okay, you can see that movement, and horizontal movement is there, and due to the movement of that conductor, so cutoff flux will be there. You can see the moving coil wound onto a former. Okay, so due to that one, you can see that electrical leads. Okay, electrical leads are there, and it is alternating output signal. You can obtain that alternating output signal, so you are able to get that signal. Okay, and you can amplify that signal as per your requirement, and you can send it to the loudspeaker. Okay, all the time actuator is not mandatory, but most of the time, especially for that application of control system in physical application, that physical application, that actuator, the operations of the actuators present is mandatory. Okay, operation. So here you can see that another figure. So permanent magnets are there, then voice coil. Okay, so sound wave that is coming from your sound is coming from your side. Okay, so how it is called, it is cone shaped suspensions are there. Chassis means outer loop, and here the sound wave is movement of the sound wave means it is vertical, it is horizontal movement of horizontal movement of air is horizontally moving, and voice coil is there, and due to the voice coil, then same thing, same process like your previous one. Then electrical leads mean electrical connectors are there. From here it is coming electrical connectors. Okay, and here you can see the permanent magnets are there, and permanent magnets means it is steady state, so it is moving. Okay, it is moving, so we will get some input signal. So here you are getting that output signal, again you are getting the input signal. The reverse thing is happened. Okay, the reverse thing is happened in the positions of that diaphragms. Okay, so the basic requirements of the transducer. So what are the most important functions? Okay, so first, the main functions of the transducer, you need to know about the function of the transducer first. So it is to respond. Okay, respond only for the measurement under the specific limit. So I am always telling you the limit is most important. So how much the range of operations, that limit you have to find out. Okay, for which it is designed. If it is beyond the limit, then it is not working properly, and that may cause for damage of your transducer. Okay, so that's why if you see any of the sensor or transducer, so you have to study first the manual. Okay, you have to study first that data sheet, or you can say like in a single word, the manual of the transducer. Okay, so if you study the data sheet of that transducer, so you can understand what is your limiting voltage, current. Okay, how much you can say like that in LEM transducer, LEM 25 LEM LV25P, the model number of LEM voltage transducer, it having 600 volt maximum, it can carry 600 volt. Okay, and how much current is there, that current is having some of the value maximum, it depends upon that model number. Okay, so it depends upon model number, it is how much value, current of value, maybe some milliampere range. Okay, so 100 milliampere, like that way. Okay, so if the you can see the current range is very low. Okay, milliampere range, but voltage range is high. So that's why you, sorry, I think 0 to 10 ampere. Okay, not very less amount, 0 to 10 ampere, I think so. So that's why what you need to do, that when you are in that case, you have to insert some, you have to design some measuring resistance. Okay, some measuring resistance, the calculations of to measuring resistance, for the measuring, the calculations for the measuring resistance is uh, is uh, is given in the data sheet of your transducer model. Okay, so of the transducer, so you have to calculate it as per that value. Okay, so and you have to insert that resistance for making that current limit. Okay, making that current limit within the range. Okay, that is first the that is first your mandatory features. Okay, so what are the important features, that is rigidness, so capacity for withstanding the overload. So how much current value it is maintaining. Okay, how much amount of current it is allowable. Okay, so this allowable through this transducer, that you have to select. Okay, so how much amount of current is there, then you can say like that linearity. Okay, so linearity range of operation means that I am a lot of time I have discussed about the linear applications, means you have to need to see the characteristics. Okay, and how much variations of their zone. Okay, so it should be, you should consider up to linear zone of operations, how much linear zone of operations are there. Okay, that you have to calculate. If it is not working in the linear zone, so you should not consider it, because of that if that zone is varying and it is in non-linear mode of operation, then it will be difficult to analysis. Basically non-linear means what, the rate of the difference. Okay, actually you can say like that, it should follow the Ohm's law. Okay, the changing in your input side, the ratio of changing in your input side to the output side, if it is not make it constant, if it is not constant, so you can say like that it is non-linear zone of operation, and it is maintaining constant, that means delta x by delta y is constant throughout the area, means throughout that operating point. So you can say like that it is linear mode of operations. Okay, so that you have to select up to linear mode of operation. Then repeatability means all the times. Okay, you are taking 10 times that result, it should give that accurate one, the same result it is coming. Okay, so that is another necessary point. So that is written the repeatability should reproduce the same output signal when the time input signal is applied again and again. So again and again, if you give that signal to the system and you are getting the same response, you say like that it is working fine and it is good instruments. Okay, high output signal quality, so signal quality is another issue. If that signal quality is not so good, so you can say like that it is not perfect for that applications, that distorted signal, so it should not be given that distorted signal. Okay, so continuous signal always be getting. Okay, so there is no, you are using only for that conversion. Okay, so distorting signal is not required. So that input is distorting, then output is coming distorting, no problem, it is significant. Okay, so input is distorting but output is coming constant, then there will be the problem. So you have to think about it, you have to think about it. So how much values are coming? Okay, so high reliability and stability. So that's why stable zone of operations. So how much range is operations is there? Suddenly you are giving the data and you are getting at absurd results. Okay, that means it is not maintaining the stability. So how the range of stability and the response time means how much time it is behaving, means you are giving input and continuously you are getting output, but after giving the input some time is required to getting the output. So how much time is required, that means it is called the response time of your transducer or a sensor. Okay, so that response time should be very less. Okay, so giving input, accurate output should be coming simultaneously. Okay, otherwise you are not select that instruments. Okay, select that sensors. So high reliability means all the time it will give you the reliable response, reliable results. Okay, if you are not getting that reliable and results for all the throughout the time period, so your transducer is not, or your sensor is not accurate one. So reliability, another most important features like your previous instruments. Okay, the same thing I have discussed lot of times. Okay, all the instruments, the reliability, stability, good dynamic response, that I have also telling you that response time. So your response is function of time. No, so how fast you are giving input and how fast you are getting the output, that is your response time. It is called your dynamic response. Okay, good dynamics response also been acceptable. The output, what is telling like that, output should be faithful to input when taken as a function of time. Okay, so function of time you are getting that output. So no hysteresis. So hysteresis loss should not be there. Okay, should not giving you any hysteresis during the measurement, means BH loop. Okay, so BH loop means you are giving some input and you are getting, so spontaneous in BH loop what happen, you are doing the test in spontaneous magnetism. Okay, so you are giving input and you are getting that output of increasing, gradually increasing that current intensity. Then VH na, so you are increasing the value of H, so it will reach some of the value B. Then again you are reducing the value of H, so it is not following the same path. Okay, so it is following the different path. So finally what you can observe, that one significant area of loss you can identify. Okay, that is taken by that magnetic materials in BH loop. So that is called hysteresis loss. The same thing also happened for your instrument. So increasing, if you gradually increasing the input of the instruments, and it will follow the same one path, and now gradually decreasing that value. Okay, in your x-axis, that same path should be followed by the instrument. If it is not followed by the same path, it will taking another path. So you can say like that there is some hysteresis loop. Okay, that hysteresis loop is not acceptable. Okay, so that may cause for additional means that may cause for erroneous results. Okay, so that's the issue. So you should not be there should not be presence any hysteresis loop or hysteresis loss. So next one is your residual deformations. Okay, due to the hysteresis, some deformation is there. If the hysteresis is there, so both of the input, that means increasing mode and decreasing mode path is not same. So in that case some of the results deformation will be there, so that is not acceptable. Okay, so both these phenomena should not be there, the hysteresis, deformation, residual deformation, that should not be there. So should be no deformation or removal or the local after the long period of applications. Okay, so long period of application it should not be there any residual deformation, hysteresis. Okay, but which points are much more acceptable? Good dynamic response. Okay, high reliability, stability, high output signal quality, repeatability, all the time that repeatability important, then rigidness, and then linearity. So the instrument should be robust in nature. Okay, so the quality of the output signal will be very good if your how high output signal quality is there. Okay, I think today I'm giving you the very basic intro of your sensor and transducer. So right now I think the slot of next class has started. So I'm today I'm complete. So I'm completing my today's session at that point. Thank you all of you.